Hello everyone, welcome to this presentation in which I'm going to introduce to you a new free software package which is KiCad for electronic design, schematics, PCB, manufacturing of electronic boards and so on. Okay. Until now we have seen Spider, which is based on WinPython, and it is useful for solving mathematical problems, plotting figures, doing analysis, design, and so on. Okay, everything related with mathematical analysis. Then we have seen LTSPI 17, which is used for simulation of electrical and electronic circuits. Okay, so this is another very powerful free software for electronics design. Today we are going to introduce KiCad, which is an electronic design software, also open software and free to use, which is useful for developing schematics, PCBs, manufacturing of boards and everything. Okay. So first of all, let's see a little bit about KiCad. If we enter into the KiCad web page in Wikipedia, we can see this information. KiCad is a free software suite for electronics design automation. It facilitates the design of schematics for electronic circuits and their conversion to PCB designs. KiCad was originally developed by Jean-Pierre Charras. It features an integrated environment for schematic capture and PCB layout design. Tools exist within the package to create a bill of materials, artwork, Gerber files, and 3D views of the PCB and its components. Okay, so we can see here more information related to this software. For example, the components. KiCad suite has five main parts. KiCad, which is the project manager, eSchema, which is the schematic capture editor, PCB new, the PCB layout program. It also has a 3D view, GerView, which is the Gerber viewer, and bitmap to component, which is a tool to convert images to footprints for PCB artwork. Okay, so we have again more information. Okay, so we can go now to the official website of KiCad. Okay, by pressing here, we can go and visit the web page of KiCad, which is this one, www.kicad.org. Okay, so we have here all the information and also the possibility of downloading the software. If we click here, download, then we have all the different versions in the different operating systems. For example, for Windows, we can click here, and then we have the recommended version for 64 bits. Okay, and then we just have to download it for one of these mirrors and then get the software installed. Okay, it's very straightforward. We have also, going back, the documentation. Here we have documents with different information for getting started, the KiCad in general, schema, the different parts, and the different programs that we have in the package. Okay, and then we have libraries. Usually the libraries are coming with the download that we are going to get in the web page, but if we would like to have the last version of the libraries, we can come here and get them and install them in our software without the necessity of installing all the software again. Okay, so let's take a look to the documents. I would like to highlight this document, getting started with KiCad. I think it's interesting to take a look to this document. Sorry, I have to click here in PDF. And then we get this document with several information related to KiCad. Okay, introduction, KiCad workflow, using KiCad, and so on. But in this introduction, we are going to pay attention to the workflow. Okay, as a first introduction, we can see here how to do all the work in KiCad, which is a typical workflow in any software dedicated to the manufacturing of PCB, schematics, and so on. So we will start here. We will create a new schematic, okay, using eSchema, and then we are going to add the different components. Okay, if the component doesn't exist, then we need to create a new component. But we are going to see this in a new video. In this video, because this is an introduction, we are going to assume that all the components that we need exist in the libraries. So we say yes here and place the component in eSchema, okay, until we finish the schematic. Okay, place all the components, do all the connections, and then get ready our schematic. When we have ready our schematic, we do the annotate of the components, which means to automatically assign a number to each reference of each component and so on. We will then perform the rule check. This is also important because with this rule check we can avoid mistakes like short circuits or connecting an input to another input, okay, and things like this. So we can solve problems, especially in very complex designs. Okay, once we don't have errors after performing the rule check, then we can go here and start to the PCB design. Okay, so we need to associate first to all the components in our schematic to a footprint. Okay, if the footprint doesn't exist, then we need to create a new footprint. Okay, but in this introduction, again, we are going to assume that we know we have all the footprints for our components. Okay, we will see how to create new components in another video. Okay, so here they say that we can do the following step in two ways. The current way, which is run cbpcb and associate each component with the correct footprint. Okay, double click and then generate netlist. Or the new way, which is right-click on each component, assign the footprint, press select button, and select the footprint with a double-click. Okay, so we can do it both ways. I'm going to do this way, the new way, because I am used to do it this way in other PCB package. So then, when we have everything ready, we generate the netlist. The netlist is a file, a text file with all the connections and all the components and the connections in our design. Okay, and with this we can go to create PCB. And for this we open the PCB new program. Okay, in this program we read the netlist. Okay. And with the netlist, we are going to get all the components in our screen, and then we have to do the PCB connections and get ready with all the connections and so on. We are going to see an example right now. Then perform the rule check again, okay, to avoid short circuits, to avoid wrong connections, and so on. And then when we have our PCB ready, then we can we can create the files for manufacturing. If we are going to manufacture the PCB in our lab, then we just want to print these files using our printer, okay, in paper, and then transfer it to a transparent material and do the manufacturing as we know how to do it. If we want to send this board to a professional manufacturer, then we need to export the Gerber files, okay, and send the Gerber files. Take a look to the Gerber files and then send the Gerber files to the manufacturer, okay. Today we are going to assume that this is a simple board and we are going to manufacture the board in our lab, so we only need to print the files on regular paper, and then we do all the process in our lab, okay. So once we have ready our installation, then we can open KiCad. Let's go here, for example, and I have ready KiCad here, okay, and then we can start KiCad, okay. So what do we have to do now? We have to create a new project for our design, okay. So it's just going here, file, okay, and then new project, and then assign a project. I'm going to save this, for example, in downloads, and my project is going to be very simple, okay. To make this video short, it's going to be an RC filter, okay. So we have with this we have created the PCB and the schematic document, okay. So first thing, as we have seen, we need to start here, double click here, so we start schema, and then we can start with our design, okay. We can see here our sheet, and then we can document everything, okay. But we are going to see only quickly the process that we have to do, and other details we can see them in future videos, okay. So here we need to do our design, okay. So we need to place the components. For placing the components, we can go here, for example, place symbol, okay, and we can also do it with this toolbar here on the right, okay. So we can press here, place symbol, and then we enter in place symbol mode. We click again, and then it is going to load all the libraries for the first time. We have to wait a little bit, and then we have all the libraries here, okay. We're going to implement a very simple circuit, which is a RC filter. So we need a resistance. Let's write here the letter R, so we can see here our sample for our resistance that we can use, for example, this one, and we can place it around here. For rotating the component, we just have to press the letter R, okay, and then we can rotate it and place it, for example, here, okay. Then we need a capacitor, so place symbol, again, click, and then select right here the letter C, and then we have here a capacitor which looks nice, so we can place the capacitor, for example, here, okay. We can end tool, as you have seen, clicking on end tool or with the escape key on the keyboard. And then we also need two connectors, okay. So we need to place, for example, another symbol, and then click again and right con, so maybe we can look for some connectors here, one connector, for example, could be like this one for the input and one for the output. Okay, so this connector looks also nice, so we can use it. We can rotate with R, and we can do the mirror with X and Y. Y is for the vertical mirror, you can see here, and X is for the horizontal mirror. Okay, so this is also good. So we can rotate. I would like to have number 1 on top, so I'm going to do it like this. Okay, and then press another one, take again, and take it and place it, for example, here. Okay, so in tool with right click and tool, or with escape, and then we need to do the wiring, for example, now. So we need to do the wiring. So for this, we go to the toolbar, for example, here, and do place wire, and then do all the connections. Very easy. Okay, always starting from the pin and ending in a pin. Okay, it automatically, as you have seen, is going to place a junction in this T junction, which is good to be sure that we have a connection here. Okay, so next thing that we have to do in our schematic is to assign values to our components. For example, resistance R, what is the value? Say, for example, 1 kilo ohm. So double click, okay, double click on the component, and then we enter this window. So the value we are going to select is, for example, 1 kilo ohm, 1K, okay, and say okay. And same thing for the capacitor, double click on the capacitor and select, for example, capacitor 100 nanofarads, okay. And then we have pretty much everything ready for going to the next step. So now we would like to assign numbers to all the references. Okay, this is also very simple to do. We go, for example, here, tools, okay, and then annotate schematic. Okay, annotate schematic. So pressed. We can use all the options by default, and then press annotate. Okay, here is giving the information of what is doing, and so we can assume this, annotate, and close. Okay, so we have our references updated. So we have J1, R1, C1, and J2. Okay, so this is good. This is really good. Okay, so another thing which is important in our schematic is to assign labels to all the nets, or at least to the important nets in our circuit, because when we are going to do our PCB, this is good because we can identify all the tracks with the corresponding nets, and then we can know if we need to take or to pay attention to this net or to this other net, make it wider, and so on. So this is really important. For example, here we're going to assign labels to the different nets. So for this, we go to this here, place net label, okay, and then click here. This is going to be our input, okay, and this one here is going to be our output, okay, output, and then this one here is going to be our GND, okay, for example, and then we end the tool and we have all the nets in our circuit with a notation. So the next step would be to perform the rule check as we have seen. Okay, so for this we go here to this button here, click here to perform electrical rules check. Okay, so we enter here and then we see this window. We can see here the report, and then here the different options that is going to be considered in our report. For example, connect an output pin to another output pin. This will generate an error. Okay, connect a 3-state pin to an output pin. This will generate a warning, and so on. Okay, so we come back here, ERC, and then press here, run, and it finishes because there is no error. Okay, but for example, imagine that we have not connected very well this connector. We are going to move it, something like this. Okay, and for some reason we forget to finish these connections. Let's see what is going to happen when we do the rules check. Okay, so press run here. Okay, and then we can see this information pin not connected. Use a non-connection flag to suppress this error. Okay, if it is not an error, because we sometimes we want to have pins unconnected, but in this case we have two errors here, and it is signalized with these two green arrows. Okay, so we can correct this by moving again, sorry, our connector, and then run again. So we can see that now the checking has finished and we have no error, so we can go to the next step. So next step will be to go to the PCB and draw our PCB for our board. Okay. For this, first we need to assign different footprints to the different components. Okay, the footprints to the different components. For this, we go to each component here, double click on it, and then select footprint here. Okay, we need to enter here the footprint. For this, we can click here in this button and enter in the different PCB libraries with the different footprints. Okay, so we press here, double click, okay, and then we see this window with the different footprint libraries, and then we can select different components. Okay, right now we are with the resistance, so we will look for some resistors. For example, here we have axial resistors, so we can select, for example, this one. Okay, double click here, and then okay, we have here assigned our footprint, so just press OK. Same thing with our capacitor. Okay, double click, footprint, double click to see the libraries, and then capacitors, we go here, for example, have tantalum, or we have this, I think. Double click here, and we have axial capacitors, radial, disc, and rectangular capacitors. So I think this is better. We can select, for example, okay, this one for our capacitor. Okay, so of course we need to know what capacitors are going to use in advance, and the dimensions and so on, and select the proper capacitor in the libraries. And if we cannot find a good capacitor for us, then we need to create a new footprint for our capacitor. Okay, so press OK in this case. So now for the connectors, we can double click here and select also the footprint I'm going to select this footprint from one library, so it's going to be this one, okay? And then also we can do like this. If I copy this description here, Control C, go to the other connector, and double click footprint and Control V and paste in the description of the component is another method to select the footprint. Okay, so right now we have everything ready. We can save our design, and then we can create the netlist. Okay, we need the netlist to go to the PCB design program. Okay, so now we go to tools, okay, and generate netlist file. Okay, so we can select PCB new, the file format. We have other formats if we like, but we can use this in our program. So generate netlist, okay, and it's going to generate this file, save. So we have our netlist. We can take a look even to our netlist. It's going to be here, RC filter and RC filter.net. Okay, so if we open this with Notepad, we can see here all the description in text. Okay, so it is just a text file. Okay, so we can go back. And now we have to go to the PCB program to design our PCB. We can do it both ways. We can go here to run PCB to layout, or we can just go to the main program and open here our board. Okay, so double click here, and then we are right now in our PCB design program. Okay. So we can see here, it is not very clear, but in red we can see in the sheet for our design, again with all the information and so on. So now the next step will be to load the netlist. Okay, and for this we can use this button here to load netlist, or go to tools and load netlist. Okay, press here, select the netlist file, which is this one, RC filter, okay, and then here we have the information with all the description, okay, that we have for our PCB, okay. So we just click here, update PCB, okay, and then close. So we can see that somewhere we have all our components. Okay, we can select all of them and move them inside our sheet. So we can do a zoom with the wheel of our mouse. Okay, maybe with this button here. Okay. So now we have to place all our components as we like. For example, we have a connector J1 on the left, connector J2 on the right, and then our resistance, for example here, our capacitor, our capacitor. With the R we can rotate. Okay. Okay, so we have ready. Maybe we can rotate this resistance to avoid crossing of the tracks, and this will be really good. Okay. So now we can see with this connection, with these lines, the connection between the different components. Okay, so we need to add tracks to do the different connections, as you know. Okay, and then we can see also the names of the nets. For example, this path here is connected to GND. This path here is connected to the input. So this is really useful because we, as we are doing the routing, we can know what is the different tracks are going to be connected and so on. Okay. So here we have on the right all the different layers that we have. Of course, sometimes we don't need all of them. Okay, the most important ones will be the front copper layer, the back copper layer, which is this one. Okay, and maybe, for example, front silk screen. Okay, with the drawing of the components, back silk screen, and maybe, for example, fabrication, okay, assembly with information for fabrication on front and back, okay. This program names front, the top layer, and back, the bottom layer. Okay, so the next thing will be to draw the shape of our board. Okay, usually this is done in this layer, on this layer here. Okay, the board's perimeter definition. So we click here and then we select. You can see this arrow here. We are selecting this layer. And in this layer, we are going to draw the shape of our board. For this, we select, for example, this, add graphic polygon. Okay, so we draw. Okay, we draw our board shape like this, for example. Okay. So now we can start drawing the different tracks. Okay, so this is very simple board. So we can draw all the tracks on the back layer. Okay, on the bottom. So we can select this. Okay, which is the back copper layer, and then with this tool here, with this button, route the different tracks. Okay, so press here and then start routing. For example, I'm going to the input path, press, and then do the routing. Okay, we can select the width for the different tracks. For example, we are using for this track right now this dimension here. Okay, 9.84 mils. Okay, we can select if we want to work in mils. Okay, which is 1,000 of inches, or millimeters. Okay, we can select with these buttons the dimensions. Okay, I prefer to work in mils. I used to work in mils, so we can select here for this dimension, or if we like, we can add new dimensions here, new widths. Okay, we can edit, and here in tracks and vias, we can add, for example, a new dimension. We can add, for example, 20 mils for some tracks, or we can add, for example, 30 mils for other tracks, or for very big tracks, for example, we can use 50 mils. Okay, and press OK. So now we can select other dimensions. Okay, say for example that we can use 30 mils. Okay, in our board. So we press here, and then we have a wider tracks. Okay, and just it is a matter of starting and ending in the different paths. Okay, as in any other program for PCB. Okay, so this is really easy to do. Okay, so we have here all the routing. So our board is almost ready. Sometimes we would like to add dimensions to our board. okay, to facilitate the manufacturing in the lab. Okay, so for this we can select, for example, the front fabrication board, selecting here, and then use this button for adding the dimensions. Okay, so with this we go, for example, here, and then we can add the dimension. Okay, but maybe this, okay, press again, and then we have here the dimensions, okay, in inches. If we want to use in millimeters, then we will have to press here and then draw it again. Okay, for example, Control Z, and then we select here. Maybe for this it is better to use millimeters. Okay, and the other dimension here, from here, and then we can see it's not very good in this case. Maybe it is better to draw it on this other line or start. I prefer to have the number on the other part, but it is okay. Maybe then go to the other side and start from here to here. Okay, and then we have the other dimension. Okay, so this is our board. Okay, with the different tracks, if we want to hide this layer, then just click here, and then we can hide this layer. Maybe we need to move this. Select first. Sorry. Select first the front silk, and then with this we need to select this tool, and then we can move this to different places. With the R we can rotate, and J2 also to place it here. So we are ready now to manufacture. Okay, so in this case we are going to assume that we are going to make our board in our lab. Okay, so we are going to print the basic manufacturing files. Okay, we can save here, and then go, for example, we go here, file, print. Okay, and we can select here the different layers that we want to print. For example, if we want to print everything right now, then we do print. Okay, select, for example, our printer in PDF, so print, and then saved. So we can see here our board for manufacturing, because we have selected now to print only the shape of the board, okay, and the tracks. Okay, we can do other selections. For example, if we want only bottom and no mask, and only cast only the shape of the board. Let's see now what we are going to get. Will be here better to have all the information together. So we can see here our board. Okay, we can check if everything is okay in the dimensions. Here we can go to, in PDF we can go to tools, and with there is a tool here for doing measurement here. Okay, measures, and we can check if our dimensions are okay. So we have here this dimension 1.16 inches, and here this other. Okay, dimension more or less, which is 0.43 inches. Okay, so these are the same dimensions that we have here. Okay, now we have then in millimeters, okay, 28 millimeters and then 11 millimeters more or less, which will be the same as this one. Okay, we can check again if we would like, go into inches and then select this dimension here, from here to here. Okay, so we can see that it is 1.15 and here is 1.16, so it is okay. We can generate other printings. For example, if we want to print only the distribution of the components, we can go File, Print, and select only the edge cuts, the shape, and also the front silks. Okay, and select. We can take a look to this print preview and see what we are going to get. So see if everything is correct. Okay, and then print. Okay, print 1. Okay, and then we can see here the distribution of the different components. Okay, so with this we finish this introduction to PCB design with KiCad. I hope this has been useful for you. In next videos we will see how to create new components both for schematics and for PCB and create our own libraries. Okay, thank you very much for watching this video and goodbye now.